Hi, my name is Sebastian Matteau, and today I want to show you 7 tricks that you can use to write better Python code. Now what I will do is I will illustrate each trick using a simple problem, first showing how many developers would probably solve this problem. I call this the bad way. And then I will show how you can use a simple Python trick to solve the same problem in a slightly more concise, a slightly faster way. And I will call that the good way. Let's start with a very simple problem. Let's say that I want to check if I'm running the latest version of Python. So here you see that the latest version of Python at the moment is Python 3. Python 4 doesn't exist yet. And my Python is also 3. I'm also running Python 3. Then what I can do is simply check if the latest version of Python is higher than my version of Python. If so, I say message is update available. Else I say message is up to date. And then I print out this message. If I select this and I run it, you will see here in the debug window it prints out update check up to date. So I'm up to date because I'm running Python 3, which is the latest version. In principle, there's nothing wrong with this way of doing a simple version check, but it can be done slightly more in a slightly better way using an inline if statement. It goes as follows. You can say message is update available if latest Python is higher than my Python. So it's almost natural language, right? It's almost just English what I'm writing here. Else up to date. In other words, I can express this logic on a single line. I can say the message is update available if the latest version of my Python is higher than my Python. Else I'm up to date. If I select this and I run it, you will see that it also works. Up to date. Now, just to check, if I say my version of Python is 2, and I run that same statement, it will say update available. Right? So, essentially this single line expresses the same logic that we expressed here in 4 lines. Now, these inline if statements can be very convenient, but they're also a little bit dangerous because they can make your code more difficult to read. So I would say use these inline if statements only if they make your code more concise and easier to read, which I think is the case in this example, but you can disagree on it. But if it doesn't make your code easier to read, don't hesitate to just take a few lines of code to express an if statement in the more in the traditional multi-line way, right? But in any case, inline if statements are a very powerful tool to have in your Python toolbox. Now, let's take this example and make it a little bit more realistic. Because say that we actually want to check not if I'm running Python 3, but if I'm really running the very latest version of Python, which at the time currently is 3.5.2. And here you see in the debug window, you see that I'm also running Python 3.5.2. Now, how can we compare this whole list of versions, this whole list of subversions, right? So the first subversion is 3, the second is 5, and the third is 2. Many developers would probably create some kind of roundabout for loop of the kind that you see here, in which we have it as a sort of a starting assumption that we're up to date. So we say message is up to date. Then what we do is we have this awful for loop, which means the following. We take the length of the list latest Python, right, which is 3 because there are 3 elements in this list. And then we turn that into a range. So we get a range 3, which would be 0, 1, 2. So essentially what it says here is for I in 0, 1, 2. But it's pretty awful. I don't like it. Then what we do is we check for each subversion whether it is higher in the latest version of Python than in my version of Python. If this is the case, we say that an update is available and we break the loop to cancel the check, right? Because we've come to a conclusion. Now, if I select this and I run it, you will see that it works. It says I'm up to date. But it's kind of bad. It's bad because it's difficult to read, in my opinion. And it's also bad because it's kind of unsafe. Because if, for example, the 2 lists are not of equal length, and that's very possible that it happens, it will crash, right? For example, if I say my Python is 3,5, I select this and I run it, I get a tuple index out of range error, and that is because it tries to compare subversion 3 from the latest Python against subversion 3 from my Python, and I don't have a subversion 3, so it crashes. So that's kind of bad. So there are different ways in which you can solve this problem. Let's start with what I think is a slightly better way. And in this solution, I will use a few tricks that I explained in a previous video tutorial, 7 simple tricks to write better Python, to which this video is actually kind of a sequel. Right? So I will just briefly remind you of how this works. What we can do is say, okay, latest subversion, for latest subversion, comma, latest my version in zip latest Python, comma, my Python. Oh. What this means is this zip function literally zips these two lists together, and it allows you to walk through these lists in a pairwise fashion. So the first time that for the first iteration, latest subversion will be 3, and latest my version will be my Python. It's kind of a weird name. My subversion. So latest subversion will be 3, and my subversion will also be 3. The second time, latest subversion will be 5. My subversion will also be 5, etc. So that's kind of, zip is a pretty sweet function for walking through multiple lists. And then we say, if the latest subversion is higher than my subversion, an update is available. And we break the loop because we've come through a conclusion. Else, the message is up to date. So what this means is basically as soon as we arrive at a latest subversion that is higher than my subversion, we break the loop because an update is available. Else, and the else in this case means if the loop was not broken at any point, if no break statement was executed, we are up to date. Right, so you understand the logic, right? If I select this and I run it, barring any typos, it will work and it says up to date. Let's just say, just to make sure, say that I'm actually running Python 3.5.1. If I run this piece of code, it will say update available. Right, so this works. Let's change it back to Python. Now, this is a slightly better way, but it's still way more complicated than necessary, because what you can do in Python is simply compare the two tuples, in this case, directly. You can just say message is update available if latest Python is higher than my Python, else up to date. So here you see we again use this inline if statement that I showed you before. And what we also do is we use Python's automatic logic to compare sequences. If I run this, you see it works. So what happens if we compare latest Python to my Python? Python will automatically walk through these two lists, or two tuples, and will compare this to this, this to this, this to this. Right? This works for any kind of iterable object. So if I turn these two things into lists, it will still work. Right? Right, so that's pretty sweet. As long as you can walk through them, Python can do this kind of automatic sequence comparison. Now, there's one thing to be aware of in this here, and that's what happens when the lists or the tuples are of unequal length. So say that the latest version of Python is 3.5.2.0 and my Python is 3.5.2. Now, I think most people would say these two versions are identical because the 0 that is here in the latest Python is kind of omitted, is kind of implied in my Python, right? So these two version strings should be the same. But for Python's sequence comparisons, actually the 0, it says update available, so the 0 here actually is considered higher than the missing value in my Python. So you should basically, the thing to remember is that the long sequences are considered higher than short sequences. So that's one thing to be aware of. But other than that, it's a very powerful way of comparing sequences in this kind of way. Okay, let's move on to the next example. Extended unpacking. Now, extended unpacking is pretty sweet, and I should say that this only works for Python 3. Now, the problem that we want to solve here is a very simple one. We have 4 cities, a list of 4 cities, and they're ordered by population. So we have Groningen, which is smaller than Marseille, which is smaller than Buenos Aires, which is smaller than Mumbai. And what we want to do is simply get the smallest and the largest city. Now what we can do, for example, is unpack the cities list and say that the smallest is the first. Then we unpack the 2 intermediate ones, Marseille and Buenos Aires, to these dummy underscore variable, and the largest will correspond to Mumbai. Select this and I run it. You will see it works and it says smallest is Groningen, largest is Mumbai. Now, but this is bad because we assume that there are 4 elements in the list, right? And that doesn't necessarily need to be the case. Say, for example, that I think Paris is slightly smaller than Buenos Aires. Say that we insert Paris here. I select everything, I run it. I will get too many values to unpack because now we have 5 list elements and we're trying to unpack it into 4, right? So that doesn't work. It's bad. Let's remove Paris again. So what you can do instead, it's a safer way, simply say, slightly better way, we can say smallest is cities 0, right? And the largest is cities -1, okay? So as you probably know, 0 corresponds to the first item from the list and -1 corresponds to the last item from the list. So if you use a negative index, you start counting from the back, and -1 is the last one, -2 with the second to last, etc. Now this is a pretty sensible way of solving this problem. If I select this and I run it, you will see it works. It says smallest Groningen, largest Mumbai. Nothing wrong with it. But Python 3 offers a very powerful technique that we can illustrate using this problem, namely extended unpacking. And it goes like this. We can say smallest, comma, rest, comma, largest is cities. Now let's remove this for the character. Now, if I select it and I run it, you will see again that it works. Smallest is Groningen, largest is Mumbai. And you will also see that print rest, if I print it out here, if I print out rest, you see it's Marseille and Buenos Aires. So in other words, what we're expressing here is that the first one should go to smallest, the largest one should go to, the last one should go to largest, and everything in between should be captured in a variable called rest. And the fact that it should be that multiple items should be captured in this variable is indicated by this asterisk. So this would also work if we again insert Paris here in the middle. So if I now run it, it will still work, it won't crash. And if I now print out rest, you see that Marseille, Paris and Buenos Aires are all captured in this rest thing. Right? So this is a pretty powerful way of unpacking lists or tuples, right? Right now it's a list because I use square brackets, but if I remove the square brackets, it will become a tuple. And if I run it, it will still work. So you can unpack both lists and tuples in this way. It's a very powerful new technique in Python 3. So if you want to write Python 2 compatible code, don't use it, right? But if you only care about Python 3, then this is a good tool to have in your Python toolbox. Now, let's move to the next example, in which we again have, we're again talking about cities. And what we want to do here is we want to create a dictionary in which the city names are the keys and populations are the values. And the cities are the same, Groningen, Marseille, Buenos Aires and Mumbai, and the populations are here. Now I'll select them, run them. Let's first take a look. I'll type this directly into the debug window. What we can do is say dict zip cities populations. And this will give us a dictionary where the city names are the keys and the populations are the values. It's pretty sweet. And the way it works is that we zip these two lists together, right? So then we get tuples where Groningen is paired with this value, Marseille is paired with this value, etc. And then when we pass that to the dict factory function, it will create a dictionary where the first tuple value becomes the key and the second tuple value becomes the value. Now that works, but you see that it actually doesn't do what we want to do, because what we want to do is capitalize the city names, and here they are not capitalized. So if we want to capitalize the city names, we have to apply an operation to these city names, and the operation that we want to apply is the function string.capwords. Now, string.capwords is a function from the string module that capitalizes the first letter of each word in the string. So it's exactly what we want to do. And then many people would probably create a loop like this. They create an empty dictionary. Then we zip the cities and the populations together. We walk through them for city, population, and zip cities, population. Then we capitalize the city name, use that as a key, and then we assign the population as a value. If I select it and I run it, you will see that it works. So Mumbai, Buenos Aires, and you see it's kind of the same as here. The only difference is that now the city names are capitalized, right? So it does what we want to do. But there's a slightly better way, or at least a more concise way, in which we can do the same thing. Namely, using a so-called Dict comprehension. We can create a dictionary in one single line of Python code. We can say, okay, D is, and then we open up curly braces to indicate that we're going to do some dictionary stuff. Then we say string.capwords, city, population. So here you see, okay, string.capwords city functions as a key and population functions as a value, right? Indicated by this column. But what is actually the city and what is the population? Well, I'll type this on the next line. Is indicated by this for loop, for city, population in zip cities, populations. And then I close the comprehension. Right, so this allows you to express the same logic that we expressed here in 3 lines of code, but then in 1 line, right? So I actually split the 1 line into 2 lines, but it's strictly speaking 1 line of code. So what it does is basically it loops through city and population, and then it capitalizes the city name, uses that as a key, and uses the population as a value, and turns that into a dictionary in 1 sweet, concise line of code. So dictionary comprehensions are kind of like list comprehensions, which are more well known, I think, but then they work for dictionaries. Dictionary comprehensions are pretty sweet. Let's select it and run it. But they can be quite difficult to read. So what I would say is use Dict comprehensions if they make your code easier to read. Otherwise, just stick to good old-fashioned, more explicit for loops, right? But at the very least, dictionary comprehensions are a powerful tool to have in your Python toolbox when you use them wisely and not to write messy spaghetti code. Now, let's move on. Again, using this example of the cities with populations. Say that now we want to solve basically the same problem. The only difference is that we want to preserve the order of the cities. So we want to stick with the dictionary where the smallest city comes first and the biggest city comes last. Now, here we have the same solution that I had explained before, right? So with the dictionary comprehension, so this is exactly the same thing that I just showed. If I select it and I run it, you see it actually doesn't do what we want it to do, because Mumbai comes first, and Mumbai is actually the largest city. And it actually, for some reason, has inversed the city order here. Now, dictionaries in Python don't have an order. Strictly speaking, that's not true, of course. They have an order because you can loop through them, and then you will get the elements in a particular order. But what people mean when they say that Python dictionaries don't have an order is that their order is not preserved. It can change, and actually it does change all the time. If you do a lot of operations on a dictionary, you will find that the order of the elements in the dictionary changes in a more or less random way. So you cannot rely on the order of elements in a dictionary. If it's important, if the order is important, then Python has a very nice object called the OrderedDict. So this is a bad way, right? Because it actually doesn't do what we want it to do. The good way would be something like this. D is ordered collections.OrderedDict Dict. So we create an ordered dictionary, which is empty. And then we say for city, population, in zip cities populations. Let's remove the space here. D string dot capwords city is population. Alright, let's remove the bad way. Select this and I run it. You see that it works. And it actually now gives the order, it preserves the order, right? So here we have an ordered dict. The first city in the list is Groningen, which is the smallest, and we inserted it first. Then we have Marseille, then Buenos Aires, and then Mumbai. So ordered dictionaries are very convenient if you want to kind of use a dictionary as though it is a list and you rely on the order of the elements in it. You also see that now in this, what I call the good way here, actually reverted back to this kind of creating an empty dictionary and then creating a for loop and filling the empty dictionary instead of using a kind of dictionary comprehension. Now, I think this problem probably can be solved with dictionary comprehension, but I think in this case, using just this good old-fashioned for loop results in the most readable code, right? And that's in the end what we want to accomplish. Okay, so here we have the ordered dictionary. A nice class to be, nice object to be aware of. Now we're moving from cities to nature. So the problem that we want to solve is the following. We have some data from a butterfly observation experiment. And the data is as follows. We observed 2 brown clippers. We observed 11 common Mormons, which are common. Only 1 giant atlas moth and 3 blue peacocks. And then what we want to know is how often we observed a palm fly. Now, the palm fly is not in the dictionary. So by definition it was observed 0 times. But how are we going to find that out? So let's say I select this and run it. Okay. Now if I say butterfly observations palm fly, I will get an error because palm fly is not in the dictionary. So I can't do that. So what many people would probably do is say if the palm fly is in the butterfly observations, then we get the palm fly key from butterfly observations and we save it as palm fly observations, else palm fly observations is 0. So we explicitly code the logic that if the key doesn't exist, there are only 0 observations. If I select everything and I run it, that works, right? But it's kind of a bad way, and I warned against it in a previous video screencast. A slightly better way is to use the dictionary get function. So the slightly better way, or it's even a good way, I think, but it's one way to do it. Palmfly observations is butterfly observations dot get. So we don't access the key directly, but we use the dot get function, palmfly, and then we specify a default variable. So the default value is 0. I select this and I run it. It will also print out 0, right? So because palmfly is actually not in the dictionary, it will return 0. That's pretty good. But if we want to do this very often, we can also make use of the good way using the Python default dict. So again, part of the collections module. collections.defaultdict. Note that default dict is all lowercase, right? Whereas ordered dict was actually using camel case with a capital O and a capital D. I don't know why this is the case. It's pretty inconsistent, but that's the way it is. And then what we do is we specify in this case lambda 0. That seems pretty complicated, but what it means is the following. We create a default dictionary, and the default value is indicated by a function, and the function that we create is a lambda function that always returns 0. So lambda is a technique to create a function on a single line of code, and that returns in this case the value 0. In other words, this def dummy return 0 would do exactly the same thing. We defined a dummy function that always returns 0, and this lambda is the same, achieves the same thing, but it's a little bit more concise. So that's what it means. And then what we do, we update our default dict with the butterfly observations. So in other words, we copy all the content from the butterfly observations into our default dict. And then we can simply say palmfly observations is the palmfly. Because now this default dict, if the palmfly key doesn't exist, will automatically use the default value. In other words, it's kind of like the dot use of the dot get function is implied in a way. If I select this and I run it, you see that it works, right? So the default dict is a pretty powerful object to use if you have a big dictionary and you just want to get elements from this dictionary and you don't want to bother, you don't want to worry about whether the keys are actually in the dictionary or not. Then you can use the default dict. It's pretty convenient. If you just don't want to do it once, then using this dict.get function is of course also a perfectly fine solution. Using this explicit if statement is pretty bad style, in my opinion. Now let's take this example and improve it even further, right? So we stick to the same problem that we had before. We have our butterfly observations, and we want to find out how often the palmfly has been observed. Now it turns out that Python has an object, a counter object, that has been designed specifically to solve this particular problem, even better than the default dict. Now, and it works as follows. Butterfly counter is collections, so it's again part of the collections module. Counter butterfly observations. So what we do, the counter object is initialized with this dictionary, indicating how often each butterfly has been observed, and it is basically a default dict for counting things. So everything that's not in the counter has 0 observations. So palmfly observations is butterfly counter palmfly. And then if we print it out, print palmfly observations palmfly observations up, and I select it and I run it, you will see that it works. So because essentially this problem in which we have a dictionary that we use for counting things, and in that case always things that are not in the dictionary have been counted 0 times, that's such a common situation, such a common problem, that there is a specific object in Python for it, which is called the counter object, right? And the counter object and the default dict are obviously very similar, but the counter object is even more specialized to solve this particular problem. Now that's it. So I showed you seven Python techniques that you may not have been aware of before. First, the inline if statement, right? That allows you to express a single if-else statement on a single line of code. The sequence comparisons, right? That basically the fact that Python allows you to compare strings of things or sequences of things with one statement, one comparison statement. So you don't need to loop through the list to compare each element one by one. The extended unpacking syntax that is only valid in Python 3, that allows you to unpack basically the rest of an unpacking operation into a variable. Dict comprehensions that allow you to, on a single line of code, allow you to generate a dictionary and apply some kind of operation to the keys and the values. The OrderedDict, that is basically a dictionary that remembers the order in which you put stuff into it. And the default dict, that is also just a dictionary, but it has a default value for things that are not in the dictionary. And the counter, that is again like a dictionary, but it is a dictionary that is used for counting stuff. And whenever something is not in the counter, it has been counted 0 times. Now, for all of these Python tricks, I think it's important to remember that Even if you know them, you don't have to use them. The goal should always be to write the most readable Python code, and for example, an inline if statement in many cases makes your code easier to read, but in some cases it can make your code more difficult to read, and then you shouldn't use it. And especially I think a Dict comprehension is a technique that can result in very messy code, so you have to use it with moderation. But knowing these Python techniques is of course always a good thing, also because it helps you to read and understand other people's code. Thank you for your attention.